Hello, this is Mr. Henry, and welcome to lesson 4.2, solving multi-step linear equations. The essential question says, how do I solve multi-step linear equations? Now, for them, I ask, if you have the expression 3x plus 4 minus 2x, what can you do to make this expression simpler? So what do you think? You might think about, well, I've got some x's here and some x's here, and I'd like to be able to combine them together. And we actually can. This expression can simplify down to this expression. And actually, that can simplify a little bit more down to just x plus 4. And we're going to learn about some of these other simplifying techniques as we go through our lesson. Because a lot of this multi-step equation stuff, most of the beginning steps of this are to simplify your equations. So we have two vocabulary words here. The first of them is the distributive property. The distributive property is when you multiply the outside number by all the terms on the inside of the parentheses. That in itself probably means absolutely nothing to you. Let's get an example. So if you have x plus 8 or whatever. So in this example, this distributive property allows you to multiply this outside number, the 3, by all of the terms on the inside. So if I could take the 3 times the x and the 3 times the 8, and I would get, well, 3x plus 24. That's what this distributive property allows you to do. And the whole point of the distributive property is it allows you to get rid of parentheses. Notice in my new line right here, no parentheses, which is awesome. Parentheses are one of those things that stop you from solving the equation the way we'd want to. It stops you from combining like terms, which is our next vocabulary word that we'd like to know. And so a lot of our goals, first goal is going to be to get rid of parentheses. Now, like terms I have here are terms with the exact same variables. Like in the previous example on the previous page, this 3x and this minus 2x are like terms because they have the exact same variable. They have an x. So that's what like terms are, just terms that have the exact same variable. On the right-hand side of your vocabulary box, you'll see something like this. It says solving an equation. Now, these are the 5 steps that you can use to solve pretty much any equation. So we'll start at the bottom and work our way up. No, I lied. We'll start at the top. So at the top, first thing we want to do, whenever you're taking an equation, you look at an equation, the first thing you want to do is you'd like to get rid of parentheses. By distributing. So we're going to use that distributive property to get rid of your parentheses first. That is usually the first goal. Now, obviously, if you look at an equation and there are no parentheses, well, then you just don't do that step. The next step. The second step you're going to do is you're going to combine like terms on each side. I should say on each side of the equation. Now, what that means is just like we did in the previous example on the first page, is if we took like that 3x and the minus 2x and combined them together to give us 1x, that's combining like terms. So these first 2 steps basically come down to simplify the problem. Make the equation look as simple as possible before you start solving. Because it's much easier to solve a simple equation than it is an ugly, complicated looking equation. For right now, we're going to skip step 3. Step 3 is what we're going to be learning about in the next lesson. So step 4. Step 4 is you're always going to get rid of the additions and subtractions, so things that are being added or subtracted to the variable. Also, these things are sometimes called, well, they're just the other terms. Get rid of other terms by adding or subtracting. And by other terms, I mean the terms that don't have the variable in it. And finally, the last step is get rid of the coefficient by multiply or divide. I'll write it out. By multiply or divide. Now, this you're familiar with. When we did those one-step equations in the last lesson, this is what we were doing. If the variable was being added by something, we subtracted. So for an example of the step 4, x minus 5 equals 12. You want to get rid of this other term. So you do the opposite. We would add 5 to both sides, and we get x equals 17. This is what step 4 looks like. Step 5 is just you're getting rid of the coefficient of the variable. You're getting rid of the number in front of the variable, the thing that's either being multiplied or divided by the variable. So if you had, say, 2x equals, no, we'll use 12 again. So you're getting rid of this coefficient by dividing both sides by 2. Cancel, x equals 6. So step 4 and step 5 are old. That's what we did in the previous lesson. Step 1 and 2, slightly new. So the first thing we would like to be able to do is we just want to get some practice simplifying expressions. This is what those first 2 steps of the solving the equation come down to, simplify. So here it asks us just simply to simplify. So we're going to take this ugly mess of a problem and make it look as simple as possible. So when you look at this, I see this says 3 times by this stuff. Well, 3 times by 2x would be 6x. And 5 times by 3, that's just 15. Hopefully you can agree that this looks simpler than that. And that's all we're doing. We're making the problem look simpler, less complicated, less extra stuff we don't need. Now, this final line here that I circled, it cannot be simplified. You cannot take 6x and minus 15. They are not like terms because they don't have the same variable. So this is actually the solution, or not solution, it's the simplified form of this expression. Letter B. Let's see, for a, well, I have an A here and an A here. The problem is this A is inside parentheses, which means we cannot combine those 2 A's together as they are. We have to get rid of those parentheses first by distributing. So we're going to take 3 times by 2a. So 3 times by 2a is 6a, and 3 times by a negative 6 is a negative 18. Already this looks a little bit simpler than it did before. Now, I can do a little bit more. I can combine this 4a and this 6a. 4a plus 6a is 10a. And that does not simplify anymore, so that would be done. I combined like terms here. I distributed here. That is simplifying. I would like you to please do these two problems. You'll notice letter D is labeled as a challenge. You might find it a little bit harder. It's okay if you get it wrong, but still make an attempt. Pause the video. When you're ready to continue, hit play, and we'll go through it together. All right, so let's see here. Letter C. Well, 3 times 2 is just 6. 4 times 5x will be 20x, and it is positive. And that does not simplify anymore. So this would be done. Got a little ugly with my circling. There we go. Letter D. Okay, so it's labeled as a challenge. So let's see how challenging this is. 3 times h and 3 times negative 5. We have to distribute to get rid of these parentheses. So this gives me 3h minus 15. This part is easy. It's this area over here that I would expect some problems to have happened. You might have just said, oh, minus 2 plus h, and just kind of drop the parentheses. But that's where the mistakes happen. That is wrong. What this actually says is this up here is a little invisible 1. This says negative 1 times by this stuff. So if you take negative 1 times by 2 and negative 1 times by h, that's why these parentheses are here. If the parentheses were not here, well, then it would just say minus 2 plus h. But there's a reason for those parentheses. It's negative times by this stuff. So negative 1 times by 2 is negative 2. Negative 1 times by h is negative h. Now, we can start combining some stuff together. We've got h's here and h's here. So let's see, I've got 3 h's minus 1 h. Remember, if there's no number in front, it's a 1. So 3 minus 1 gives me 2 h's. And I've got a minus 15 and a minus 2. Well, minuses and negatives are the same thing. So negative 15 minus 2, that's going to give me a negative 17. You could think of it as negative 15 plus negative 2, negative 15 minus 2, or any combinations of negatives and minuses, but this does simplify down to that. And that's as simplified as we can go. So let's now see some of this stuff in our equations. So the directions say to solve the equation, and be sure to check your answer. So here we have, it says 6m plus 11 equals 83. If we'd go through our checklist that we wrote out for solving equations here, get rid of parentheses, combine like terms. Well, there are no parentheses, and combine like terms on each side. On this side, there's nothing to combine together. On this side, there's nothing to combine together. So there's no simplifying needed here. So we're going to jump down to the step 4, which was get rid of the add and subtract, or get rid of these other terms, the terms that do not have a variable. So this is my variable. You always want to get rid of this multiply last. So you have to get rid of this plus 11 by subtracting 11. 6m equals, see, 83 minus 11 gives me 72. Step 5, we're going to get rid of that multiply by 6. So we're going to divide by 6. See, 6 divided by 6 is 1, which gives me 1m, or just m. 72 divided by 6 is 12. So I think that this is the solution. I'm going to check it though. So I'm going to take 6 times by 12 plus 11, and hopefully we get 83. Let's see, 6 times 12 is 72. 72 plus 11 is 83. That checks out. So my answer, M, equals 12. Letter B. So I can split up my two sides here. Let's see. Can I do anything to simplify this side? Are there any parentheses to get rid of or any like terms to combine? No. Can I do anything to simplify this side? Well, yeah. I mean, this is not distributive property. This is just multiplication. But why have 7 times by 2 when you could just simply have a 14? So let's do that, and it just makes the problem just a little bit easier and prettier to look at. All right, so let's solve this thing. You're always going to get rid of the multiplies and divides last. So we need to get rid of this minus 13. The opposite would be to add 13 to both sides. These cancel out. B divided by 3 equals 27. And now my variable is being divided by 3, so the opposite of divide by 3 is to multiply by 3. Okay, so if I multiply by 3 on both sides, this times by 3 and this divide by 3 are opposites. They give me cancel, gives me 1b, which is just b. 27 times by 3 is 81. All right, so I think the answer is 81. Well, let's check. If I take 81, divide by 3, and subtract 13, do I get 14? That's the question. We don't know. So 81 divided by 3, the order of operations says you divide first. So divide here gives you 27, and 27 minus 13 does give you 14. It checks out. So the answer, B, equals 81. So you kind of get the feeling for how this works. You kind of go through your checklist. You check each side. Can you simplify anything on the left? No. Can you simplify anything on the right? Yes. After you've simplified everything as much as possible, then you start doing the solving. So you get rid of the other terms, the things that do not have the variable in it, by adding or subtracting. And then you should be left with the variable and a coefficient. It's either being multiplied or divided by something. And you do the opposite to solve that equation. And you're done. Here's 2 more we'll go through together. So letter C. Draw my line down the middle. All right. Can I simplify anything on the left? No, it's just a number 20. There's nothing to simplify there. Can I simplify anything on the right? Yes. I've got these parentheses that if I distribute, the parentheses will be gone, and I can do some more solving stuff. So if I distribute here, it gives me 12k minus, or 4 times negative 4 is negative 16. That is now a little bit simpler. Okay. Well, since you're going to get rid of this multiply last, get rid of the minus 16 first. So I'm going to add 16 to both sides because that gets rid of a minus 16. 20 plus 16 is 36. I'm now going to divide both sides by 12 because that's the opposite of multiply by 12. And I get k equals 3. Okay, let's check it. 20 equals 4 times 3 minus 4. So order of operations says you do this stuff inside the parentheses first, and multiply comes before subtraction. So this gives me 9. 9 minus 4 is 5. 4 times 5 is 20, which does equal 20. This checks out. So k does equal 3. Letter D. May not look too pretty, but it's really not that bad. So we start by separating our two sides. Can you simplify anything on the left? No, it's just a number. Can you simplify anything on the right? No, there's no parentheses, there's no like terms, there's nothing just to add or subtract or combine together or multiply, so we just start solving. So now, since we're going to get rid of this coefficient last, we're going to get rid of the minus 14 first. And the way you get rid of a minus 14, if you remember from before, is by adding 14. Remember, this is a negative 14 plus this 1/9. So we need to get rid of this negative 14 by adding 14 on both sides. Well, these cancel out. You get 1/9 d equals, on the other side, negative 8 plus 14. Let's see. That's going to give us a positive 6. I'd like to say I'm 100% sure, but I'm like 80, 90% sure. Negative 8 plus 14. Ooh, messed up. 8 negative plus 14 equals, there we go. Now I'm 100% sure. I had a little doubt in the back of my mind, so I just want to check my calculator to make sure I'm correct. Now, the way we learn to get rid of a fraction being multiplied by the variable, you can either divide by the fraction if you have a calculator that can do it, or you multiply both sides by the reciprocal. 1 times 9 is 9, 9 times 1 is 9. So these two give you essentially 9 over 9, which equals 1d, or d. And on this side, 9 times by 6 is 54 over 1, which is just 54. Okay, let's check. Negative 8 equals negative 14 plus 1/9 times by 54. This is not pretty in itself, but it's not ugly. It's not terribly hard to do. 1/9 times by 54. Let's see. Let's see if my calculator is going to give me a bad answer. Times by 50, backspace, times by 54 equals, okay, and simplify, so 6. And negative 14 plus 6. 14 negative plus 6 equals, look at that, negative 8. It checks out. So we're combining old stuff and new stuff. Okay, here's 4 for you to try. Go ahead, pause the video, try them on your own. When you're ready to continue, hit play, and we'll go through them together. Okay, so let's see how you did. Separate your two sides. There's nothing to simplify on either side. So you start by solving. I'm going to subtract 6 to get rid of this add 6. 1/3 h equals 8. The way I'm going to get rid of this multiply by 1/3 is I'm going to multiply by the reciprocal. Times by 3 over 1. This cancels out because you get 3 over 3, which equals 1h, or just h. And over here, you get 24 over 1. To check your answer, 1/3 times by 24 is 8. 8 plus 6 is 14. That works. So I did the checking in my head instead of writing it out, just to save a little bit of time. Letter F, separate your sides. Nothing to simplify here, nothing to simplify here. Get rid of the multiply, divide last, so you get rid of this first. I subtract 2 to get rid of an add 2. 9r equals 36. Divide both sides by 9 to cancel out a multiply by 9, and r equals 4. 9 times by 4 plus 2. 9 times by 4 is 36. Plus 2 is 38, which checks out. Letter G. Let's see, nothing to simplify, nothing to simplify. So getting rid of this divide by negative 4 is last. So getting rid of this negative 3 up front here is first. So we're going to add 3 to both sides. 7 equals. Now, this might have caused some people a problem, this extra negative here. I see a lot of students who forget about that negative, who as soon as they get rid of this minus 3, they think, oh, this guy disappears along with it. That's not true. If it was a plus sign, yeah, kind of. It doesn't really disappear, we just don't write it. But if it's a negative sign, you have to keep it. It is still a negative w over 4, or a negative 4. And since the w is being divided by a negative 4, we can multiply by a negative 4 to cancel it out. So the negatives cancel, the 4's cancel because one's to divide, the other's to multiply. It gives me w equals, and over here, negative 4 times by 7 is negative 28. And if you checked it out, it does work out. That is the correct answer. Letter H. The first problem where there's actually any simplifying needed. On this side, you can simplify those two. 5g plus 3g is 8g's. Over here, 15 and 9 combine together to give you 24. So we got some simplifying. We combined like terms. Now, divide by 8 on both sides. These cancel. G equals 3. And you can plug it in here even. 8 times 3 is 24. It works out. Okay. So I'm going to start increasing the difficulty a little bit with some of these problems. So if you could please, go ahead, pause the video, try these two on your own. When you're ready to continue, hit play, and we'll go through them together. Alright, let's see how you did. Let's see, left side. Oh yeah, we can combine. Negative 9r plus 3r is a negative 6r. Yeah, we can simplify here a little bit. And since there's no variable over here, we could distribute and combine. Or we could kind of do this in our head. We say, well, 1 plus 2 is 3. So this stuff is 3. And 4 times 3 is 12. So this is just ugly just for the sake of being ugly. We can pretty this up, and it just equals 12. All right. Solving our equation. Let's see, the variable doesn't have any addition, so we just get rid of this times by negative 6. So we divide by a negative 6. R equals negative 2. Check our answer. Let's see, negative 6 times by negative 2. Does that equal a positive 12? The answer is yes, it does. Letter J. There's nothing over on this right side to simplify because it's just a number 26. But on the left side, I've got parentheses here with a variable inside. So I'm going to distribute here. Get rid of these parentheses. Gives me 2m minus 16. And now that this m is free, he's no longer in parentheses, I can actually combine those two terms together. They're on the same side. I can just add them. Well, subtract them in this case because they're different signs, but a negative 3 plus 2 gives me negative 1m. And now I'm going to get rid of this negative 1 last, so I get rid of this minus 16 first. So I add 16 to both sides. Negative 1m equals 42. Divide both sides by negative 1. M equals a negative 42. And if you plug it in and check, I like to check after I did some simplifying. So here, You could plug in the whole way up here, and you would still get the same thing. So negative 42 times by negative minus 16 equals 26. Well, this negative 42 becomes a positive 42. Minus 16 equals 26, and yep, that gives you 26. This checks out. All right. I believe these are the last two just straight solving problems. So go ahead, pause the video, solve these two on your own. When you're ready to continue, hit play. We'll go through them together. Okie dokie. Let's see. Simplify. Oh yeah. 2 squared is just 4. 5b minus 7b. Yep, that can simplify. Those are like terms, which gives me negative 2b. And then if we divide both sides by negative 2, b equals negative 2. And 5 times negative 2 minus 7 times negative 2 equals 4. So 4 equals, this is negative 10. This is minus a negative 14, which becomes a plus a positive, which, yep, that equals 4. This checks out. All right. Letter L, the ugliest of the bunch. There's nothing over here. That's just 24. But on the other side, let's see. Distribute. Get rid of those parentheses. So that gives me a 4g plus 4 plus 2g. And there's a negative 4 out there. Let's see. I've got g's and g's. So 4g's and 2g's combined together give me 6g's. And I also have a minus 4 and a plus 4. Now, minus 4 plus 4 equals 0. They cancel. They have different signs. So this guy and this guy cancel out. Makes my life easy. All right, so let's see. 6g equals 24. There's nothing being added or subtracted to it, so I divide by 6 on both sides. Cancels. G equals 4. And you can plug that back in, check your work, and believe me when I say it does work. That is the solution to that problem. So let's do some applications. Letter A says, to rent a booth at the county fairgrounds costs $42 per day, plus a one-time equipment fee of $85. Find the number of days Mr. Batzel rented a booth if he paid a total of $337. Okay, so let's see. I'm going to start with the verbal model. So I'm imagining, this guy has to pay some money to rent a booth. So what's he paying for? Well, he pays this $42 per day. So I'm going to put dollars per day. And he also has to pay for this equipment fee. So money for equipment. And together, that would give you the total amount of money. This is my verbal model. Okay, so now the amount of money per day is $42. And the amount of money for the equipment is $85. And the total is $337. Now, I intentionally made this not quite right. I want you to check to see if you can find out where the mistake is in my equation in the second step. Did you spot it? It's right here. You're not just paying this $42 one time. You're paying this $42 every day. So if he's there for one day, he pays $42. If he's there for 2 days, $84. 3 days, you get the idea. It's $42 every day. So since that thing is happening over and over and over and over again, it is a multiplication. Also, another way you could have thought about this is the thing that it's asking you to find the number of days he rented a booth. You don't know how many days. That's your missing piece. That's your variable. So that's what you have to find to solve this equation. So there's our equation. Now if we solve that equation, we get our answer. Oopsie. There's no simplifying needed. This doesn't simplify, that doesn't simplify. So I'm just going to start solving. You get rid of the 42 last, so you get rid of this 85 first. And minus $85 on each side, giving you 42D equals, calculator says, 337 minus 85, $252. And then we would, since this is a multiply, divide by 42 on each side. And we get, divide 42 equals 6. So the number of days would be 6. 6 days times by $42 a day plus the one-time equipment fee of $85 would give you a total of $337. So that's exactly the number of days Mr. Batzel rented the booth if he paid $337. Okay? So we have our verbal model, we have our equation, solve the equation, get our answer. That's going to be pretty much the same steps you're going to use in almost every word problem, every application. Letter B. A farmer has a field with 19 rows of pumpkins and a small side field with 12 pumpkins in it. So this is kind of like that corn problem from the last lesson. So let's see. He's got a field with 19 rows of pumpkins, boom, 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 and a small side field with 12 pumpkins. Okay? Both fields together, both fields have a combined total of 107. So if you take this field plus this field, you get a total of 107. All right. So I'm going to say pumpkins, P-U-M-P-K. Yeah. I'm going to try that word again. Pumpkin in the big field plus pumpkin in the small field equals total. This is my verbal model. The total is 107. It says so right here. The pumpkins in the small field is 12. It says so right there. The pumpkins in the big field is, we don't know. Well, let's finish the problem. It says here, if the farmer doubled the number of pumpkins in each row of the large field, how many pumpkins would he have? So we don't even know how many are in each row right now. We just know that the 19 rows plus some number in each row, we'll call it maybe P for pumpkins, plus the 12 is 107. 19 in each row times by the number of pumpkins in the row. This is how many pumpkins are in the big field. We don't know what that is yet, but that is how many pumpkins in the big field. 19 times by how many are in each row. Okay, so let's solve this equation. Let's figure out how many pumpkins are in each row. Subtract 12 on each side. 19p equals 107 minus 12. 95 divided by 19 divided by 19, and the pumpkin total is 95 divided by 19, 5. So there are 5 pumpkins in each row. 19 rows, times by 1, 2, 3, 4, 5 pumpkins in each row. And it's a little side field of 12 gives us a total of 107. All right. Now that's not the answer to the entire question. That's the number of pumpkins in each row. The actual question says, and this is the reason why this is a DOK2, because it's an extra step harder, it says if the farmer doubled the number of pumpkins in each row of the large field, how many pumpkins would he have? So all of this work was needed to find out how many pumpkins are in each row. So if we double that, if we say now there are 10 pumpkins in each row, plus the little side field of 12, the question's asking, how many pumpkins would he have? So we had to find the number of pumpkins in each row in order to continue the problem. So let's see here. If he doubled the number of pumpkins in each row, I can tell right now, 19 times by 10, that's going to be 190. So our big field plus the small field equals the total. The big field has 190. The small field has 12. The total, we don't know. Well, let's figure it out. 190 plus 12 is 202. So, how many pumpkins does he have altogether now? He would have 202 total pumpkins if he doubled the number of pumpkins in each row of the large field. Letter C. It says Nathan is an avid stamp collector. For 9 weeks he bought stamps. If we add those to his collection of 45 stamps, he now has a total of 252. How many stamps did he buy each week on average? Go ahead, pause the video, do it on your own. When you're ready to continue, hit play, and we'll go through it together. Alright, so he collected stamps for 9 weeks. And if we add those to the 45 he already had, we have a total of 252. So this would be like our verbal model. Now, the stamps for 9 weeks, we don't know how many he got. We know he collected for 9 weeks. The question is asking, how many stamps did he buy each week on average? So if he bought 3 stamps each week for 9 weeks, 9 times 3 plus 45, is that going to give us 252? Well, no, that's probably a little bit too small. We want to know how many did he buy each week. So how many stamps, I'm hesitant about using an S for a variable. I'll use it. The problem is S's and 5s, at least for me, look very similar. So I know that's something I just have to watch out for. You could also use, W for weeks or something like that. So 9 times how many he bought each week, how many stamps he got, plus 45 gives us our total of 252. There's our equation. So let's solve. Subtract 45. 9s equals 252 minus 45 is 207. Divide both sides by 9. S equals, divided by 9 is 23. So on average, he got 23 stamps each week. Because if he collected for 23 stamps a week times by 9 weeks, that would give us 207. and then you add the 45 stamps he already had, gives you the total of 252. So there's my check of the math. It all makes sense. 23 is our solution. Here's another DOK2. It says, given a right triangle, remember right triangles, Pythagorean theorem, that whole business. Given a right triangle, find the size of the angles if one angle is 10 times more than 4 times the other angle, and the third angle is a right angle. Pause the video, try it on your own. I would highly recommend you draw a picture, and when you're ready, continue, hit play, and we'll go through it together. Okay, so the goal, the thing we're trying to find is find the size of the angles. That is what we want. So if I draw a picture, we know that one of them is a right angle, so that's 90. We know that one angle is 10 more than 4 times the other angle. So I'm just going to call the one angle A, I guess. A. The other angle is 10 more than 4 times that guy. This angle here is 10 more than 4 times the other angle. See what I'm saying here? See how this picture kind of helps out? So one angle is 90. One angle I just threw as some letter A for angle. And this angle is 10 more than 4 times this other angle. Now, how does that help us find out how big these angles are? Well, if you remember from a triangle, all the angles of a triangle added together equal 180. I mean, this is the first thing I thought of because I would just have angle measures, 90, this thing, this thing. So if I would take this 90 plus the A plus the 10 plus 4A, all together, that should equal 180 degrees because it's a triangle. All triangles add up to 180 degrees. Well, let's simplify. We just got ourselves an ugly equation. So I've got an A and a 4A. Okay, 5 A's. I've got a 90 and a 10. 90 combined with 10 gives you 100. And this side stayed the same at 180. Let's solve. Minus 100. 5A equals 80. Divide by 5, cancels. A equals 80 divided by 5 should be 16. Let's check it. There we go. So we are saying this math is showing us that the A is 16. So this A would be 16 and that A would be 16. So now I know 2 of my 3 angle measures. I know this guy is 90, this guy is 16, and if I do the math here, I'll know how big this angle is. So let's see. 10 more than 4 times 16. Well, 4 times 16, I believe, is 64. So 64 plus 10 is 74. So my belief is that we have a 90, 16, 74 triangle. And just because I want to make sure I'm correct, if I take 90 plus 16 plus 74, I should get, look at that, 180 degrees. So I found all 3 angles of that triangle. And that's what I want us to do. Find the size of the angles of this triangle. If you could, please pause the video. Answer this question. It says, how do you solve multi-step linear equations? Go ahead and do it right now. And here I have. To solve multi-step linear equations, you start by simplifying each side of the equation. That's the distributive property and the combining like terms. Then you get rid of the terms without the variable by adding and subtracting. Finally, you get rid of the coefficient by multiplying or dividing. And there we go. This has been lesson 4.2. Thank you for watching.